In the last learning target, we simplified absolute value expressions and gained understanding of the concept. Now we're going to learn how to graph absolute value functions when we have unknown values. So in the last learning target, we had just numbers. We were simplifying numbers inside absolute value symbols. Well, just like we can graph lines, we can also graph absolute value functions. And the absolute value function looks like this. It looks like y equals absolute value of x. And we're going to talk about this being something called the parent function. Now, a parent function is your simplest, this is a definition for you guys. This is going to come up later too. It's the simplest function in a family that preserves the entire shape, that preserves the shape. And I'll show you what I mean by that. So, a parent function typically doesn't have any numbers in it. It just has your variables. And your, in a line, your parent function for a line is this, y equals x. That's your parent function for a line, because it's your most basic equation that will give you a line when you graph it. Don't write this down on your grid, but when you graph a line into your parent function, it looks like this. It has a y-intercept of 0. It goes up 1 over 1, up 1 over 1. That's y equals x. That's your parent function. All other lines are derived from that line. So if I have a line that looks like y equals, you don't have to write any of this down, I'm just saying. If you have a line that says y equals 2x minus 1, okay, there's the y-intercept, up 2 over 1, up 2 over 1. Do you see how this green line, it's still a line, it's just kind of moved and tilted around from the red parent function, okay? So if we're talking about absolute values, and we're talking about the absolute value parent function, what does that kind of graph look like? So I'm going to pick your basic values that we pick when we make a table. So my basic table numbers are -2, -1, 0, 1, and 2. Now those numbers always are what we want to start off with the basics to finding points, because it gives us a little bit of negatives, it gives us 0, and it gives us a couple positives to see what this shape might look like. Going forward, whenever I give you a blank table, it's always a good idea to try and start with these values. Not all the time, but it's usually a good bet that these are your good x values to pick. So now when I plug these in, I'm basically taking now this -2, and I'm saying, okay, y, and I'm plugging it, I'm saying y equals the absolute value of whatever x is, -2. So I'm plugging each of these in. So I'm replacing x with the x in the equation. Okay, so see how this is where all the x was right here? I just replaced it. Now, I can say, okay, when x is -2, y is going to be +2. When x is -1, y is +1. When x is 0, y is 0. When x is 1, y is 1, and when x is 2, y is 2. So I just plugged in those values for x, and I got my corresponding y's, okay? That's how you find points anytime you graph something, is you plug in an x value and you get a y value, and then those give you coordinates. So now I'm going to go ahead and plot these points. So I've got -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. So by logical thinking, I'm going to assume I also have numbers here, here, and here, which is true. The absolute value of 3 is 3, 4 is 4, and 5, and so forth. So the absolute value graph parent function looks like a V, which is pretty cool. Okay, so this is your absolute value parent function. It starts at 0, 0. Okay, it starts at 0, 0 and has a slope of up 1 over 1 on each side. See how that's my rise over run on both sides of my V? So starts at 0, up 1 over 1. That is your parent function, and that is something you need to memorize how to graph. Okay, so we're going to use this idea of this guy, this V graph right here starting at 0, and we're going to use that to graph other absolute value functions that have numbers in them. Okay, so I'm going to show you what I mean. So here we go. I've got 4 different types of graphs we look at. Okay, the first one is going to be taking the parent function, the y equals, remember, I'm going to write that up here. The parent function is this. There's your parent function. So what I'm going to do, and I've graphed the parent function on each of these already. So the blue graphs you see are the parent function graphs. So the first way the parent function can change is by taking the parent and adding 1 or adding a number inside the absolute value brackets, okay? What this does, oddly enough, is that this will take your graph and shift it over to the left. So the little guy that starts in the middle where it starts at 0, it's actually now going to start here. And it's still going to go up 1 over 1, but I'm just basically taking this V and I'm moving the whole thing over 1. Okay, so that is going to be a left shift by 1. Okay, so that's what happens if you add 1 inside. Okay, what happens if I subtract a number on the inside? So let's say that I do the absolute value of x minus 2. Now, instead of adding a number, I'm now subtracting a number. Well, that actually is going to move your middle point to the right, however many that is. So see how that's 2? So I'm going to move the point to the right 2, still going to go up 1 over 1. Up 1 over 1, that doesn't change. I'm just moving this V to a different starting place. So that is a right shift 2. Now this could be a 3 or a 4 or whatever. You'd still just move it to the right however many the number is. I'm just using 2 and 1 as an example. So in our notes here at the bottom, see how this says x plus h? Right, I'm looking right here, and I'm looking right here. Well, let me change the color of that there. See how it says f of x equals x plus h and f of x equals x minus h? So this is kind of like the formula. So if you have x plus a number inside the absolute value, it's actually going to be a shift left. Now that's weird because you think plus sign, you think right, but it's actually when it's inside the parentheses, it's opposite. So here when you subtract a number, you shift right. Okay, now there's 2 other options to move this graph around, and that's moving it up and down. So let's say, for example, now I have something like x, absolute value of x, and then I say plus 1. Now that's not shifting left or right at all because there's nothing on the inside. However, if we have a plus 1 out here, that is going to actually be shifting up by 1. So I'm going to move my point right here in the middle, move it up 1 and then make my other points. I'm just taking that starting point and moving it up 1. Notice how in all of these, the shape stays the same. It's just letting them move around. Okay, so adding a number outside is a shift up. And then finally, when we subtract a number outside, so if I have something like y equals the absolute value of x minus 2, that actually now is shifting down 2. So I'm going to go 1, 2, put my main point on 2, and then go up 1 over 1 for the rest of them. It's really important, guys, that you keep your graphs really nice and neat. If you do something like this, where you just go like, meh, and like that, that's an ugly looking graph. It needs to look as nice and straight as mine. I've got straight edges you guys can use for this unit to help you make graphs look really nice, okay? Okay, anyway, so subtracting a number outside is a shift down. Okay, so this leads us now that we know how all the ways we can shift differently, up, down, left, and right, now we're going to talk about how we are going to shift in left and right, up and down all together. So when I want you guys to describe shifting for these, I'm going to ask you several times to talk about whether you're shifting or reflecting or whatever. I want us to know of these words as horizontal shift and vertical shift. So a horizontal shift is translating that parent function left or right. And we call that in the little equation H. A vertical shift is then shifting it up and down. And we call that K. Now this is going to come up way later in like unit 11 as well, but I'm introducing it now so we can kind of get it won't sound as crazy when you hear it in a few months. So let's practice shifting these equations from the parent. So again, the parent function is graphed in the middle. Let me use a different color here. It's the blue one in the middle. That's the parent function is just graphed on there. And so I want to graph this equation without making a table of values. So I've got two shifts going on. I've got a shift going left 2 and then down 3. The left coming from here and the down coming from there. Down 3 negative, and then even though it says +2, remember a plus inside is really going to the left. So now I'm going to go start at the middle of the grid and count 1, 2 to the left and 1, 2, 3 down, and that's where I'm starting my graph. And then I just go up 1 over 1, up 1 over 1, like that. Okay. The next one, I'm going to have a shift right 1 from this inside part, and then I'm going to shift it up 2 from that. So I'm going to go start from the middle and go right to the 1, and then up 1, 2. So there's my starting point, and then I make my up 1 over 1 sloped lines to make a V. Number 3, I've got a shift to the right 4. That's coming from in here, and then, oh, not left, sorry. Then down 4. Left and right on the inside, up and down on the outside. So it's going to go 1, 2, 3, 4, and then 1, 2, 3, 4. So my new starting point is right there. Make my my lines, my slopes. In this case, the two lines overlap on the parent function. That's okay. That doesn't really matter. I just want you to be able to see that the parent is that starting V in the very middle. And then finally, the last one, that is a left 3 from here and an up 1. So I'm going to go 1, 2, 3, and then up 1. Okay. Okay, there's one last thing we have to talk about in this learning target, and that's something called a reflection. What happens if we put a negative sign in front of the function? This is called a reflection. Okay, and you're going to see this. What happens is, and I didn't put it on your notes, and I wish I had, but a reflection is instead of, sorry I didn't put this on there, guys. Okay, so this is your normal parent function. Sorry, oh, wait, hold on. Okay, let me get my brain on here. This is your normal parent function, right? This guy right in the middle, that V. A reflection is what happens when we flip it like a mirror. So this is a reflection. You're basically taking that and you're like flipping it. You're flipping it over like it's a mirror image. So you're reflecting it. So instead of the V pointing up, basically the V points down. Okay? So the next exercise I want us to do is without the graph, I want to write an equation that matches the description. So all of these equations are going to start with y equals. So the first one, y equals. Here I have a reflection, so it's going to have a negative in front of it. Then I have a shift to the right 7, so that's going to be x plus 7, and then a shift down 2. In fact, I have an idea here that will make this a little bit easier for you to see on here. Okay, I have a plan. We're going to put y equals on all of these. We're going to have an x in all of them. And then I'll use colors to help you with the rest of it. Okay, so this one, shift right 7. So that is going to be a plus 7. There's my right shift. It also has a down 2, so there's a minus 2. And then it also has a reflection, so there's my minus. So my shift right 7, there's plus 7. Shift down 2, there's my minus 2. And then I put a negative right in front of the equation like that. Okay. Number 2, shifting up 4. Well, that's just the plus part at the very end. So shift up 4 is just saying the absolute value of x plus 4. I'm not shifting left or right, so nothing needs to be on the inside. The next one is a shift left 6. Left 6 is actually going to be a plus 6. And then reflection means I put a minus sign in front of it. And I also realized I made a mistake up here. This up here should be a -7. See how easy it's even easy for me to make a mistake, because when I see right 7, I think +7, but it's the opposite when it's inside. Okay. The next one, shift to the right 2. Well, we just talked about that. That's actually going to be a -2 on the inside. The next one says shift right 4, shift up 5. Right 4 is a -4, and up 5 would be a +5. And the last one, shift left 3. Well, that's going to be a +3 on the inside. Shift down 8, that's going to be a -8 here. And then a reflection means I'm going to have to put a minus sign in front of that. Okay? So lots of things to really kind of remember. But I think that if you make yourself a little note card, or, you know, have your notes next to you as you memorize these left, rights, up, and downs, it starts to become pretty simple. Okay, the practice is very short. It might not take you very long, but I won't let you use the note card on a mastery. So if you make a note card, so just make sure when you get to mastery you feel really comfortable with it. Okay, good luck.